Students, in this video we are going to discuss about mesh analysis. So given a circuit, to find out current through any element in the circuit or to find out voltage drop across any element in the circuit, this mesh analysis will be very much helpful. So I have taken this particular circuit to demonstrate mesh analysis. The first step that you got to do in mesh analysis is identify the number of meshes in the given circuit. So here you can see that there are totally three meshes. One is from VA, R1, R2. This mesh. The second one is R2, R3 and R4. This mesh. Third one is R4, R5 and VB. This one. So there are three meshes. Second step is to assign mesh currents for every mesh in either clockwise direction or anti-clockwise direction. So I am going to assign mesh currents I1, I2 and I3. All the three currents I have taken it in the clockwise direction. So the second step to assign mesh currents is over. Mesh currents. The third step is to apply Kirchhoff's voltage law for every mesh and write the loop equations for all the meshes. So the third step is to apply KVL. Apply KVL to all meshes. In the previous videos, we have seen how to apply Kirchhoff's voltage law to any closed loop. So now I am going to apply KVL to this closed loop. This closed loop, that is the first mesh. So the polarities of the voltages across R1 and R2 are given with respect to the mesh current I1. So mesh current I1 is considered for giving the polarity. So current entering terminal is positive, current leaving terminal is negative. Current entering terminal positive and current leaving terminal is negative. So now I am going to start from this node, traverse through the entire loop and write the loop equation. So while traversing, I meet this potential across R1 first with the positive symbol coming first. So it is plus I1 into R1. And the next potential is potential across R2. Here two currents are involved, that is I1 and I2. While writing mesh equation for the first mesh, consider I1 to be greater than I2. So it is I1 minus I2 into R2. So it is I1 minus I2 into R2. So while crossing this potential, it is a negative coming first. So it is minus VA. Sum of all potentials is equal to 0. This is my first loop equation. So while writing the second mesh equation, the polarities of the potentials across these elements R3, R4 and R2 are to be considered with respect to I2. Similarly, while writing the mesh equation for this third mesh, the polarities of the potentials across R5 and R4 are to be considered with respect to I3. So I'll write the second mesh equation now. I2 into R3 plus, now I am writing the mesh equation for the this particular mesh. So it is I2 minus I3 into I2 minus I3 into R4, and for R2 it is I2 minus I1 into R2. Sum of all potentials is equal to 0. This is my second loop equation. Similarly, we can write the third equation, that is the third mesh equation. Okay, I3 into R5. While crossing this VB, it is the positive coming first, so it is plus VB plus I3 minus I2. because I'm writing this particular mesh's equation, so I should take I3 greater I3 minus I2 into R4 is equal to 0. So this is my third equation. So now let me rearrange these three equations slightly, like what are the coefficients of I1 and what is the coefficient of I2? It is R2 into I2. There is no I3 in the first equation, so let me write as the coefficient of I3 is 0 is equal to VA. Similarly, in the second equation, the coefficient of I1 is minus R2 and the coefficient of I2 is R2 plus R3 plus R4, and coefficient of I3 is minus R4 is equal to 0. Similarly, for the third equation, I1 coefficient is 0. There is no I1 in the third equation, and I2 coefficient is minus R4 and I3 coefficient is R4 plus R5 is equal to minus VB. So here I have just rearranged these equations, first, second and third equation, just I have rearranged it like this, such that I get it as I1 coefficient, I2 coefficient, I3 coefficient, and is equal to a constant. So this will be helpful for you to form a matrix and solve these three linear equations to get I1, I2, I3 values. Students can solve these three linear equations straightly to get I1, I2, I3. Or these equations can be written in the format of matrix, and then you can use Cramer's rule to find out I1, I2, I3. So let me tell that also now. Please convert these three equations into matrix format. So it is like first I1, I2, I3 is equal to what is in the right hand side of these three equations, that is VA 0 minus VB. So I1 coefficients are R1 plus R2. Here it is minus R2. I3 coefficient 0. Here it is minus R2. R2 plus R3 plus R4. And here it is minus R4. So here it is 0 minus R4. And here it is R4 plus R5. So this is matrix form of representing these three equations. So you can find I1 by using Cramer's rule, that is del 1 by del. I2 is equal to del 2 by del, and I3 is equal to del 3 by del, where del is equal to, please consider this as R matrix. So del is nothing but determinant of this R matrix, and del 1 is determinant of this matrix. That is, you have to replace the first column by the right hand side vector. R3 plus R4 minus R4, 0 minus R4, R4 plus R5. So del 1 is determinant of this matrix, where this R matrix, in the R matrix the first column is replaced by the right hand side vector. Similarly, del 2 is nothing but determinant of R1 plus R2 minus R2, 0. You have to replace the second column with the right hand side vector. So it is like this, 0 minus R4, R4 plus R5. Similarly, del 3 is determinant of this matrix. So the third column of the R matrix has to be replaced with the right hand side vector. Students can either solve these three equations, linear equations straightly, or they can use Cramer's rule. That is, they can use these three formula to find the currents I1, I2 and I3. This is how mesh analysis is done. So now let me tell you how to straightly write this matrix by looking at this circuit, how to write straightly the matrix so that it's easy for the students to solve the problems. Okay, so immediately when you see three meshes, you form a 3 cross 3 R matrix. You form a 3 cross 3 R matrix and multiplied with 3 mesh currents I1, I2, I3, okay, is equal to, you please make a right hand side vector and I'll tell you how to write this these potentials. Okay, so first point is the first element, that is in the R matrix, this is first row, first column, first row, second column, first row, third column. Similarly, it is 2 1 2 2 2 3, that is second row, second column, second row, third column, third row, first column, third row, second column, third row, third column. So to write the first element, okay, you have got to sum all the elements involved in the first mesh. So sum of all the elements in the first mesh, that is R1 and R2. So how many resistors are there in the first mesh? Only 2. So sum it and write it here. So 1 1 means in the first mesh, 1 with respect to 1. Here 1 2, that is what is the common element between the first mesh and the second mesh. So what is the common element? R2. R2 has to be written along with a negative sign. And what is the common element between first and third, first mesh and third mesh? First mesh and third mesh, no element, so it is 0. Similarly, what is common element between second mesh and first mesh? It is again R2 with minus sign. So whenever it is between one mesh and the other mesh, it should come with one negative sign. 2 2, which means that 2 with 2, that is sum of all elements in the second loop. For 2 2, it is sum of all elements in the second loop, so it is R2, R3 and R4. And for 2 3, it is the element between second mesh and the third mesh, so it is R4 and it comes with a minus sign. Similarly, 3 1, what is the common element between third mesh and the first mesh? No element, so it is 0. So 3 2, what is the common element between third mesh and the second mesh? It is R4, so it comes with minus sign, minus R4. 3 3, that is all the elements within 3. Okay, sum of all elements within 3, so it is R4 plus R5. So I have taken it as the elements R4 plus R5. So in the right hand side vector, according to the loop direction that you have taken, it is from minus to plus. Okay, we are traversing from minus to plus. It is a voltage rise, so we give it as plus plus VA. Okay, plus VA. Here there is no potential involved in the second mesh, so it is 0. And here the supply that is connected here is VB, and the polarity has to be like, when I cross this VB, it is from plus to minus, so it is potential drop. I give it as minus VB.